I apologize, my sound was a little messed up, but your time is up. So, what do we get? 1, 2, 3, 4, 5, 6, 7. We'll start Sharik, Kamoy, Brian, Sebastian, Hezekiah, here. Go.
We'll do it 40.
40, okay.
49.09.
Okay. You agree here? So 3 people think 40, you said 49.409. 40. 40. Seems to be overwhelming support for the answer of 40. The correct answer is 40 inches. Now, we have not studied the Pythagorean theorem. You have memorized it, but we've never used it, or at least you've never used it because I asked you to. So, my students who drew a picture, I'm extremely proud of you because you helped yourself tremendously by doing it. So here's the picture that would have helped for my other students who didn't draw one. A TV screen is a rectangle. So you start out with a basic rectangle. Here's the piece of information that maybe you knew and maybe you didn't, but this is true for all televisions and monitors and laptop screens and every type of technological screen that exists in the United States. The measurement that they give you, the 50 inches, is the diagonal distance from the top left corner to the bottom right, or the bottom left corner to the top right. It is this distance here. So that was an important part of the picture, and here is why. This is the part about the Pythagorean theorem you may know or you may not. What does the Pythagorean theorem apply to? It applies to something particular. Triangles, but not all triangles. It's a specific type. It applies only to right triangles. So, a squared plus b squared equals c squared applies to right triangles. So, does it apply to my picture? Hezekiah?
Yes.
For those of you who can't see it, what if I change the picture to this? Might help. Let me back up. This is what it was. Let's put in the rest of the information. The screen is 30 inches high. The diagonal distance is 50. What is this? Still looks a little confusing, but again, if I now white out this right here, you can clearly see that this is a right triangle with one piece of information missing. Any questions so far? Now the last part about the Pythagorean theorem that you may not have known. Which letter matches which side? Brandon?
A squared matches the top right.
Well, match up, I have 30, 50, and x. So A is equal to what? Yeah, the small side of the right triangle is A. Not A squared. This is A. So what is B? What is B? Zabari? B is the longer leg. That's B. Which means that this final piece right here is C. Does anyone remember the fancy name of that side of a triangle? Alyssa? That's the hypotenuse. So you plug in the numbers and letters and you solve the equation. A squared, 30 squared, plus b squared, in this case, is x squared, equals c squared, which is 50 squared. Simplify and solve the equation. So, there's comments or questions. Ania and then Brandon. Okay.
Maybe A was 30, but B was 50. Because we found by X. So
And you got the right answer? I don't know how, so I'll come look. You must have made another mistake somewhere that canceled out the first mistake. Well, I'll take a look at your paper. Brandon.
Is B always the longest leg?
Yes, A is the short leg, B is the long leg, C is always the hypotenuse. Go ahead. Then it wouldn't matter. Just wouldn't matter. That's right. You basically solved this. You just kind of did a couple of steps in advance. But you did the same thing. Here's what you end up with. You solve this. You simplify this. You get 900 plus x squared equals 2500. Subtract 900 from both sides. You get x squared equals 1600. I have not taught you how to deal with the x squared yet. So for now, what you need to think of is this. X times x equals 1600. X must be the same number, so you have to think to yourself, what number times itself will give me 1600? And in this case, the only possible answer is 40. Okay? So Anne, I appreciate you sharing. You basically did this step from here to here in advance. That was great. Okay? Catalina, and then Hezekiah.
Can't you just do the square root?
You can if you know how to do that. If you know how to do that, that's what you'll learn later on in the year, but if you didn't know that, then you'd have to think logically. Okay? So, Pythagorean theorem applies to right triangles only. A is the small leg, B is the long leg, and C is the hypotenuse. Any comments, questions, or concerns? Anything at all? Okay? Today, we start chapter 8. I do not want you to copy, I want you to look. Put your pencil down and read. Chapter 8. I'm sorry, I said put your pencil down, but you actually have to read. So, chapter 8 is going to seem like a little bit of a side trip. We have spent this whole year studying equations, linear equations, graphing linear equations, graphing linear inequalities, then systems of inequalities. It was a building process from the first day you came in all the way up to this last test you took. Now, all of a sudden, we're going to take a little bit of a side trip. It's all related, but it's going to seem quite a bit different. One nice thing that I think of, and for some of you I think you'll find the challenge interesting, is that you're going to be dealing with lots of simplifying expressions, and it's going to seem very puzzle-like. And there's actually many ways to find the answer to the puzzle. So for some of us, that could be an interesting process. But here's what we're going to be studying. It's all about exponents. We're going to learn some different methods for simplifying, multiplying and dividing expressions with exponents. You're going to deal with zero and negative exponents, which you were introduced to last year, but we're going to work with at a very high level this year. And you're going to learn how to use scientific notation to solve real-world problems. The chapter is 6 sections. We are doing 3.5 of them. So it's going to go really quick. You're going to be having to test on chapter 8 by next week. Okay? Comments, questions, concerns so far? So we're going to jump in today and we're going to be learning multiplication rules. So there is quite a bit to digest. So, example 4. So here you go. Simplify that expression. Stop. What are you doing? Don't simplify that expression. Why would I tell you? That's example 4. Do you have any idea how to simplify that expression? You guys were going to give it a go, and I appreciate that, but I would never expect you to be able to do that. But I am showing you up front, 45 minutes from now, you will have some idea of how to start. It'll still seem difficult, but you'll have an idea of where to start. So we will be doing these 2 questions today, towards the end of the lesson. Now, today's lesson is not like some of the other ones where I start with the hardest and then I go backwards to the easiest. That won't work here, because you don't have the building blocks that you need to be successful. So I am going to be teaching you 1 building block at a time. Okay? Comments, questions? Good. Here are the building blocks. These are the multiplication properties of exponents. You actually have to know the names, and you have to know what they mean. Unfortunately, the names all sound the same. So it's going to be a bit of a struggle for some of you to remember which one is which. The first property is called the product of powers property. If we replace some of the words with more common words, product means multiply and powers means exponents. So if we're multiplying expressions with exponents, this is what we can do. So, if we multiply powers that have the same base is a critical piece. They have to have the same base, then we can add the exponents. So if we have a to the m power times a to the n power, same base, multiplication, add the exponents. It's a trick. It's a shortcut. Here is a practical example. 5 to the 3rd power times 5 to the 5th power. First of all, is it a multiplication problem? Yes. Do they have the same base? Yes. Since they have the same base, you can do 3 plus 5, and that's how we get the 8. So let's go into the why. If I asked you to rewrite 5 to the 3rd power in expanded form, what would it be? 5 to the 3rd power. Caleb? That's exactly right. It would be 5 times 5 times 5. So watch what happens. 5 times 5 times 5 is 5 to the 3rd power. So we rewrote it in expanded notation. Now it's going to be multiplied by this. How do I write 5 to the 5th power in expanded notation? Maria?
5 times 5 times 5 times 5.
How many 5s are there? Ania? There are 8 of them. And what operation is being done between all of them? What operation? Hezekiah? So now, if I asked you to rewrite this whole expression as a power, what would it be? True?
5 to the 8th.
5 to the 8th power. So this is the reason why it works, because this and this are the same. So you have your choice from here moving forward. You have your choice. You may, anytime I ask you to do this, you may rewrite it like this and then find the answer, or you could use this property and find your answer. I leave it up to you to decide which way makes more sense to you. Are there any questions so far? That's the product of powers. Power of a power. My favorite property of all time. Power of a power. When you have a power brought to another power, what can you do? You can multiply the exponents as a shortcut. Here is what it looks like. A to the m power, that's the first power, is being brought to yet another power, the n power. A shortcut is a to the m times n. Here's a practical example. 5 to the third power to the fourth power. Power of a power. A shortcut is you multiply this times this to get the 12. Why does that work? Well, this exponent here means do this 4 times. So here's what that looks like. Where's my... There it is. Means do that 4 times. That's what this exponent tells us to do. Now look at this and look at this up here. Isn't this now the same thing as this situation? So now expand this. 5 times 5 times 5. Times 5 times 5 times 5. Times 5 times 5 times 5. Times 5 times 5 times 5. How many 5s are there? Anissa? There are 12. 5 to the 12th power. So, you get the same answer either way. So from now on, in my class, you have 2 choices anytime you are faced with a situation like this. You may rewrite it like this, then rewrite it like this, and come to your answer. Or, if you'd like, you could use the shortcut and do that times that and get your answer that way. I leave it up to you to decide which way makes more sense to you. Are there any questions or comments? Finally, power of a product. What? Didn't we do that one already? Power of a product. Power of a product means we have a multiplication problem that's being brought to a power. For those of you who don't know why I said that silly statement, the first one we did was product of powers. The word product came first, powers came last. This is now power of product. Power comes first, product comes last. They're different. Yeah, you have to know which one's which. To find the power of a product, find the power of each factor. So, here's what it looks like. You have a product, a multiplication problem, A times B. That multiplication problem is being brought to a power. Bless you. So what it means is each factor gets brought to the power. So this factor, A, will be brought to the m power. B will get brought to the m power. This is only with multiplication, not with addition and subtraction. Here's a practical example. 5 times 6 to the third power will be the same as 5 to the third power times 6 to the third power. Yes?
So basically, for the product of powers, you multiply, you add the exponents for powers with the same base, but for have of a product, you separate like the bases if they have the same exponent.
That's right. And now I'm going to say something sort of risky. It has the same feel as the distributive property. It's not the distributive property at all, but it has the same feel to it. Because basically what we're saying is this power is going to get put onto that factor, and this power is going to be put onto that factor as well. It's kind of like the distributive property where we multiply the number times everything inside. It's not the distributive property, but it has a similar feel to it. Are there any comments, questions, concerns about any of these? All right, well that's just the introduction. Now we're going to put it all into practice. And here's what's going to happen. We're going to do the first building block, and you will probably be fine. We're going to do the second building block, and you will probably be fine. We're going to do the third building block, and you will probably be fine. Then we're going to put it all together, and you're going to lose your mind. But that's okay, because you've been in my class now for 7 months, 6 months, 7 months, whatever. And you're used to the fact that your mind's going to be blown, and then you'll start to get it after a little bit of time. You guys are very, very smart young people. Remember what I told you way back at the beginning of the year. You guys used to expect to get it instantly. Some of you still do expect to get it instantly. You might not. Give it some time. But let's start with the building blocks. Here we go. Product of powers. Like I said, it's going to start pretty simple, and then it's going to get complex at the end. Four to the third power times 4 to the fifth power. You have two choices. Do not do what I'm going to do right now. I will tell you when to start. But you have two choices. You could do this. Okay, that's 4 to the third. That means 4 times 4 times 4 times, and then that means 4 times 4 times 4 times 4 times 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the answer is 4 to the 8th power. If you'd like to do that, you may go ahead and do that. Anyone have a shortcut for that so I can save myself some time? Brian? Same base. So I actually don't have to do that if I don't want to. I have a shortcut at my disposal, and I can say, oh, well, it's a multiplication problem. They have the same base, so add the exponents. So we get 4 to the 8th power with no effort. As I said, I'll leave it up to you. You decide which way you would like to do it. You can expand it and find the answer, or use the shortcut. Which way would you like to do it? Sebastian, which way makes sense to you right now? The shortcut makes sense? Diana, which way makes sense to you? Expanding it or using the shortcut? Shortcut makes more sense? Okay, we'll see if that continues. What about part B? Now, for the first time, we're seeing 3 factors. Y to the 4th times y to the 5th times y to the 6th. If I want to, we can expand this as y times y times y times y times y times y times... I can keep doing that. Or I could do what? And? So, can you do that mentally? What will we get? Y to the 15th power. What 2 things have to be true that will allow me to do that shortcut? 2 things have to be true. Anissa? Base has to be the same, and what's the other thing have to be true? Catalina? Has to be multiplication. This does not work for addition, subtraction, and division is different. You're going to learn that next time. So those 2 things have to be true. Any questions? Good. We're doing well so far with this building block. Let's see how we do here. Give me a thumbs up if you think you know what that's going to be already. I think you know. Shelby, what do you think it is? Okay. Kamoy? 6 cubed. That's an advanced thing. Okay. Alyssa, do you agree? You think it's 6 cubed? Okay, everybody, give me a thumbs up if you think what they said is the correct answer. Yeah, that's right. But I only see a 2 here. Where did the 3 come from? I don't get it. Could someone explain, please? Alicia? That's true. If you expanded there 3 6s, I love the way you said that. If I expand it, it's 6 times 6 times the other 6. Beautiful statement. Is there another way to look at it? Another way? Hezekiah? Mm-hmm. Yeah, could someone remind us from Ms. Cooper what she taught you to kind of, in a funny little way, remember that there's a 1 there? What did Ms. Cooper say? Kayla? Yeah, skinny little Ms. Cooper hanging out up there. Someone in the other class said something funny because then we realized that there's actually skinny little Ms. Cooper. Skinny little Ms. Cooper's here. She's there. And then she's also underneath everybody here. So someone said, Skinny little Ms. Cooper's everywhere. So, yes, she did that to try and help you remember it in just a cute, funny way. But obviously it worked because you guys remember. So any comments or questions on part C? So now let's really try and get looking at things carefully. What about part D? Give me a thumbs up if you think you know already what the result will be. Maria, you think you know? What do you think it is? Okay. Give me a thumbs up if you agree with her. Okay. Stephanie, you think something different. What do you think? Oh, you do agree with them. So what was it again? Okay, so where does the 8 come from? Where does the 8 come from? Because now I see this times this and then a 7. So that's a little confusing to me. Cherie?
There's little skinny Cooper next to the first letter 3.
Yeah, it's a little bit harder to see when it's written this way, but yeah, there's skinny little Miss Cooper right there. And for those of you who do have trouble seeing it, if I rewrote it like this, then it would be very clear to you. So it's really, in this case, just about the way it's written. Any comments, questions so far? Okay, let's see how we do on our own with the first building block. You got 2 questions, you got 1 minute. Remember, with checkpoints, you do not have to copy the question, you just need to find the solution or the simplified version, whatever. Oh, I apologize, the sound is still not working. But your time is up. So, part A, what'd you get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jada, we'll start with you, and then Eric. What'd you get? Okay, what'd you get, Eric? The correct answer is -4 to the 9th power. What about part B? What do you get? Start with Catalina and then Sebastian.
W to the 4th.
Okay? So they are in agreement. The correct answer is W to the 14th power. Comments, questions on either of those? Give me a thumbs up if you got both of them correct. Put your thumb down. My first prediction was spot on, right? I said I would teach the first building block and you would probably get it. I was right. Let's go to the second building block. Second building block, my favorite property ever. Power of a power! Power of a power. So, now you have to shift your mind, because now it's a different scenario. It's not the same property. Now we have a power being brought to yet another power. And the shortcut tells us to do what? Shortcut tells us to do what? Anissa? Multiply the exponents. So if you wanted to, you could say, okay, 3 times 5, so this is going to be 7 to the 15th power, and that's it. Now, if you rather, you could write it all expanded. So you could do this if you wanted to. You could write 7 to the 3rd times 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 7 to the 3rd, and then 7 times 7 times 7 times 7 times 7 times 7. Should I keep going?
Yes.
No? Oh, yeah. I'm going to go to my grade book now and adjust the person who said yes. Trying to torture the teacher. I'll show you. So, no, I don't want to keep going because that's ridiculous when I have this shortcut at my disposal. But the important part is to understand why the shortcut works. It works because of all of that I was just doing. But the result is easy to find. Comments, questions, concerns?
Yeah, for the expanded version, like, when you do 7 to the 3rd times 7 to that, you don't have to, like, once you, like, you don't have to, like, actually write 7 times 7.
Once you get it like this,
yeah, you can just use the, the product of piles property and just add it
yeah.
up.
So now we could use the first property that we learned and say, oh, well, it's all the same base, and they're all being multiplied, so I can add all the exponents. You're absolutely right. Okay? I was trying to prove a point. Okay? So what about part B? Give me a thumbs up if you think you already know what part B will be. Stephanie, what do you think? Okay, x to the 10th power is proposed, and you give me a thumbs up if you agree. X to the 10th power. Good, put your thumbs down. So we're starting to see not so hard to find the end results. Comments, questions, concerns? But now you're going to be faced with more complex situations such as these. So part C looks nasty. It looks nasty, but it's not really that nasty. It looks nasty because now we've got parentheses, we got brackets, and we got a negative number, but it's actually the same thing. There's nothing different about it. It may look a little more intimidating, but it's nothing different. The base is -2. The first power is 4, the second power is 3. So what will the end result be for this expression? Jada? -2 to the 12th. Ania, do you agree? Yeah, it's -2, but watch how we write this. Be careful with your negative numbers. Negative numbers go in parentheses to the 12th power. And that is the simplified form. Part D is here to prove a slightly different point. That this right here is a different situation. And we're not ready to study that yet. You're going to study that in Chapter 9. So what you have to understand and take away from this is that the whole base is this whole thing. That's the base. So if you notice, the base here is in parentheses. So if we keep this base together like this, the base is b minus 1. Now just deal with the exponents. So what will the exponent be to simplify this? Elisa? 24. Yeah, it's 24. 6 times 4 is 24. Now, this is not a case where you can now take the 24 and apply it to the b and apply it to the 1. Because that other property only works with multiplication. This is subtraction, which is basically the same thing as addition. Okay, was that what you were going to point out? Oh, go ahead. What was your other thing? You sure? Are there any comments or questions on the second building block, the power of a power property? All right, let's see how you do on your own. Checkpoint number 2, 2 questions. You got 1 minute. Okay, so what'd you get for part A? Good, lots of confidence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We'll start with Alyssa, Tristan, Zabari. Okay, what'd you get, Tristan? Zabari? Okay, Zabari, do you also have part B? Okay, hold on a second. So, part A is d to the 20th power. Zabari, what'd you get for part B? Okay, Kayla, do you have the same thing? What was it again? Yeah, w plus 2 to the 60th power. Give me a thumbs up if you got both of these correct. Okay, put your thumbs down. So my second prediction was spot on. Everyone understood the second building block. Good, we're doing well so far. Example 3, the third building block. Power of a product. Boy, they all sound the same. Power of a product. We're doing one example and then we're going to jump into the more complicated stuff. Power of a product is the one that I said had the similar feel to the distributive property. So here's the product. 2 times D times E times F. So this is really what it says, and you're going to actually start doing this next time I see you. We're going to be rewriting things like this. The multiplication dots are really important. It helps you remember what's going on. And so what's going to happen is this power is going to get applied to each factor. That's a factor, that's a factor, that's a factor, and that's a factor. So here's what it looks like. 2 to the 7th times d to the 7th times e to the 7th times f to the 7th. You can write that without the multiplication dots as a final answer if you want to. You could write it like that, or you can write it with the multiplication dots, either. And that's it. There's nothing else we can do. In one of my other classes, the students was about to say, oh, well, then we can just combine these together. How come we cannot add these exponents together and make it one thing? How come we cannot do that? Got a lot of people who think they know. Jada? They are not the same base. And so we can only add the exponents if they are the same base. Yes, and then yes.
If you wanted to, could you simplify to this?
You could. It's kind of going to take a little experience to know when you should and when you shouldn't. The publisher sometimes randomly puts things multiplied out, and then sometimes it puts it as an exponent. I can't quite figure out why the publisher did what it did. I will accept things usually two ways. 2 to the 7th power, the power is very high. Don't do it. If it was 2 to the 3rd power, that we can do quickly. 2 times 2 times 2, that's no big deal. So kind of try to use your judgment. And you're going to see an example in a minute of one where we are going to multiply it out, and you'll see why. Does anyone have any questions about power of a product? So we got the 3 building blocks. Let's see if we're ready.
We are not.
Now, the first one is going to take us a while. It's going to be a beast of a question. You're going to get frustrated because of how much it seems like you have to do. But we're going to do it the long way on purpose so that we can start exploring ways that we can cut it short. Or, I'm sorry, kind of cut things out. In other words, we're a very bright group of young people. We can do lots of mental math. But if we don't understand why things are happening, then you're going to mess things up. So I want you to see why things are happening first, and then we'll do the shortcuts. So, first of all, we have a complex expression here. First thing you need to make sure of is everything being multiplied? Everything is being multiplied. Yes, we have multiplication here, and then we have a power out here and a power out here. That's important because if there's addition or subtraction in there, that's totally different. Now, here's the one part that you did not know yet. You know the 3 building blocks, but you don't know what to do first. And it's simple. We start outside and work our way in. We start with the power of products. We start with the powers on the outside. And I'm going to take it a step further just so that we can focus. And I'm going to get rid of this part of the expression just for a couple of minutes. So, we're going to be very formal about how we write this first time. Please follow along with me. So we have a -3, and it's going to be brought to the 2nd power, so we're going to write -3 to the 2nd power. The second factor is j to the 2nd. So we're going to write that as the base, j to the 2nd, and that is also going to be brought to that power. Yes. You sure? Okay. The third factor is k to the 3rd. That's the base that's going to be brought to that power. That's the last property that you learned, power of a product. Does anyone have any questions on why we did what we did? The only thing we really did was this. We took this 2 and applied it to each factor. Are there any questions? Okay, let's put back the rest and do the same thing here. This whole expression is being multiplied by this whole expression. And now we're going to have a 2 brought to the 3rd power. 2 to the 3rd power. The second factor is j to the 2nd. Again, j to the 2nd being brought to the 3rd power. And then the third factor is a k being brought to the third power. So again, the only thing that was done was this 3 was applied to each factor. Does anyone have any questions? Now we want to simplify each factor. So you can think of it like this. I'm going to try this. What's negative 3 to the second power? Negative 3 to the second. Alicia? That's 9. So underneath it, we're going to write 3. That was 9. Here's the second factor. J to the second to the second. What does that become? Anita? J to the fourth. What property is that? Hezekiah? You sure? Yeah.
Yes.
So this is J to the fourth. And this is being multiplied. Do that. Now the third factor, k to the third to the second. What will that become? Shelby? Very good. K to the sixth power. What property was that? What property was that, Anissa? Power of a power. And so hopefully you're starting to see what is happening is that we are simplifying all the power of powers now. So now we've got 2 to the third. Well, what's that going to be? That's not power of a power. That's just powers. What's 2 to the third power? Kayla? Two to the third power. 8. That's not a power anymore. It's just a number 8. And then what about j to the second to the third? What does that become? Sharik?
J to the sixth.
J to the sixth. And what about k to the third? That's just k to the third. Does anyone have any questions on how we got from here to here? Now we have one final step for simplifying. And now you can sort of think of it, it's not, but you can sort of think of it as like terms. It has a similar feel to it. It's not like terms at all, but has the same idea. You want to put numbers with numbers. So now all we're doing is mentally rearranging everything. The number is going to go with the number. What's 9 times 8? 9 times 8. Alyssa? 72. So we've done with the 9 and the 8, 72. Now we want j to the fourth, j to the sixth. Same base being multiplied together. What will that become? Right? J to the 10th. What property is that?
Yeah.
Product of powers. Very good. J to the 10th, and we're done with that, and we're done with that. And finally, we have k to the 6th, k to the 3rd. What will that become when we multiply? Brandon? K to the 9th. What property told us that we could do that? Product of powers. Nothing else can be simplified. That is in simplest form. Tristan.
Multiply or add the exponents.
You have to know the properties. You just learned them, So for you right now, you might want to look back and see which situation matches. So in other words, look at this. If I spotlight, let me spotlight it really well. So now look at that expression, j to the second to the second. Now look back at your notes and find the property that looks like that. What is it? Good. Now read what it says to do. Good. So now you know what to do in this situation, right? Does that make sense? So for now, go ahead and look back. But by tomorrow, or maybe by Friday, you should know it here. That's the goal. Some of you already have figured it out. That's okay. Any comments or questions? Now, before we do the next one, we are extremely high level. So we want to be able to do this at a higher level. Is there some aspect of the work that I've written up there that you feel personally you can do mentally? What do you feel like you could have done mentally that you didn't actually need to write down? I'm not calling on you. You seem to do everything. Brandon? You were saying all of it? Yeah. No, that's not going to work.
I was going to say that the numbers that don't have variables.
The numbers that what?
They don't have variables.
Oh, the numbers that don't have variables. Yeah, you could do that mentally. Absolutely. So we could have, once we did this right here, we could have jumped to right here. So that's what I'm looking for, is I'm looking ways we can jump over things. Well, honestly, I'll tell you my opinion, and then you guys decide for yourselves. The next one we're going to do, we are going to skip this entire line of work. Because, honestly, I feel like you are strong enough mentally and mathematically to skip over that step. But you really have to pay attention to what you're doing, okay? So we're skipping it on paper, we're doing it in our head. We're not skipping the step, we're just skipping the writing part of it. So let's look at this one. I am going to help myself so that I do not make a foolish mistake, but you have to start with the powers that are furthest on the outside. So this power is going to be applied here. In the previous example, I wrote 25 to the third power, and then I figured it out. Now I'm going to do it all myself. I might need a calculator. I can do 25 times 25 in my head, but then I can't do it again. That's a little too much. So you might need your calculator. So what's 25 to the third power? Zabari? It comes out to 15,625 times. I am going to continue using multiplication dots so that I keep things straight. Now I'm going to apply the 3 to the a to the second, but I'm going to do it mentally. So I have to know in my head that that's a power of a power. A to the second to the third, what will that become? Anissa? A to the sixth. So I skipped a step on paper, but I'm writing it down. I'm writing down the results. Times. And now b to the third, that's easy to do. We don't really have to think much about that. It's just b to the third. Now, the second part of the expression. The 2 is going to be applied to the 1/5. How do you do 1/5 to the second power? How do you do that? Can't be done in your calculator because on the EOC you won't have that type of calculator to use. You have to know how to do it. How do you do that, Sebastian? What is it? It is not 1/10, unfortunately. Here, let me write it down off on the side so my students can see it. Maybe it'll make a little more sense. Catalina?
Well, the way I did it, I'm not sure if it's the same way you did it, but I did 1 divided by 5 and then multiplied that by 3 instead.
You could do that, but you're wasting your time. You could do that, and it's totally appropriate, but it's just, we're trying to be good at algebra, but we're also trying to be efficient with it. Alyssa? Yeah, it's just 1/5 times 1/5. And how do you multiply two fractions together? Yeah, so what does it come out to? This is why you have to be careful with mental math. What does it come out to, Eric? 1/25. You guys are making too much of this. 1/5. 1/5 times 1/5. 1 times 1 is 1. 5 times 5 is 25. 1/5 squared is 1/25. So, I didn't really want to take a side trip for that. You should have known how to do that already. You will learn more about how to do that next time as well. So you do have to be careful when trying to skip steps with things that you're not 100% sure about. Fractions. So that's 1/25. Now we apply the 2 to the b. That's just b squared. Apply the 2 to the c. That's c squared. And then we have this lonely a sitting over here. So we skipped over, comparing it with the first one we did, we skipped over this entire step, but now we're here, and we still have simplification to do. So we start with numbers, because numbers are going to be put first. So what's this times this? What do we get? Sharif?
625.
Yeah, it's 625 because basically this is saying take this number and divide it by 25, you get 625. So we're done with that, and we're done with that. What's next, Anissa? Good. To the what? A to the 7th. We got A to the 6th and A, and we put those together, you get A to the 7th. What's next? What's next, Kezekiah? B to the 5th. We got B to the 3rd and B to the 2nd, and when we put those two together, we get B to the 5th. And what's next? Kayla? C to the 2nd power. It was all by itself. It didn't have any partners, so it's just C to the 2nd power. So you can see that this seems much more manageable compared with this. Comments, questions on either of these? Ania and then Jada. Order as far as what? Of what? I just couldn't hear you, that's all. The order of what? I didn't hear you. Just say again what you said.
The order, like, if you put the numbers and they're being multiplied.
Give me an example from here.
If you put the A7 first, it was better, right?
You're saying the order of the letters?
Yeah.
The order doesn't really matter, but traditionally we go in alphabetical order. What she is asking is this any different? Is that any different? No, it is not, because if we plug in a value for b, it's all going to be multiplied, so it doesn't really matter. But traditionally, if we are using letters that are kind of in sequence with each other, we put them in alphabetical order. Okay? But I would never mark you wrong if you wrote it like this. Yes, Elisa? That's a coincidence in this case. Did that happen here? That happened here too. It's actually a coincidence. Okay? Good. Let's see how you do on your own. Checkpoint number 3. Okay, time is up. So, what do we get? Nice to see a lot of confidence. Very good. We will start with Brandon, Brian, and then Alyssa.
12
Okay,
12 times 12 times S.
that's the same thing he said. Okay, Alyssa.
12 times n to the 12 times.
So all 3 people agree, and that is the correct answer. Is 12 n to the 12th, s to the 10th. Comments, questions, concerns?
You said it's okay if you like separate these by the multiplication.
Yes, multiplication dots is fine. Okay. Any comments, other comments, questions? Good. Yes.
What if I didn't put the multiplication sign between the 12 and the 10? Does it work?
Yeah, it's fine. Okay, draw a line across your paper. Your classwork is page 82. You're doing 29, 27, 24, 23, 19, 18, 15, and 7.
Not ready to do you need to be because you're not doing the property side. So, what properties represent the power of the power? Power of the power. Power of the power says to. That's right. So, what should the answer be?
Okay, colored pens up. Here we go. 29. There's 3 different parts. A was 10 to the 4th tons. B is 10 to the 12th tons, and C is 10 to the 18th tons. 27. The missing number was 6. 24. 36p to the 12th. 23. 81 m to the 31st power. 19. 81 x to the 4th. And then from there, got pretty basic. B plus 1 to the 6th. A to the 18th power. And 9 to the 21st power. Yes, Keziah. Well, that's fine, but then you missed the point of the lesson, which is we're trying to work with powers. Yes, there are cases where we multiply things out, like -3 to the 4th power is 81 because that's simple. But when you have a scenario where you've got power of 18 or power of 12, you're not going to write that out. The whole point of powers is to be able to write huge numbers in a simple way. That's the whole point of it. Okay? So there's nothing wrong with what you did, but you got to think about the purpose. All right, comments, questions on any of these? Okay, well, let's back up for a second. Let's count A, B, and C separately. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions. So figuring out your percent on today's classwork is easy. So everyone make a fraction out of 10. Give me a thumbs up if you got 80% or higher. Good, put your thumbs down. No questions at all on anything. All the questions you got wrong, you already know where you went wrong? Alicia? 24, Kamoy? 24? Okay, so let's take a look at number 24 because I was also working with one of your classmates on number 24. They were also getting very confused. So let's simplify things a little bit. And this is something you should do for yourself to help yourself along. Let's change the question. Let's just do that. So what property is being illustrated here? What property is being illustrated? Alyssa? Power of a power. So this really means the 3 is going to get brought to the second power. Now we can do that mentally. What's 3 to the second power? Of course, you can only do it mentally if you do it right. What's 3 to the second power? Mia? 9. So we got 3 to the second power is 9. Watch what I'm going to do. 9. I'm going to put a multiplication dot. Because some of you are struggling because you're lumping things together when you need to view them as slightly separate. Now I'm going to do p to the 5th to the 2nd. Now I have to look up the property, power of a power. What does the property say I'm allowed to do when I have power of a power? Kayla? No, I don't want to, never mind. Go ahead. Well, you can even look it up if you're nervous. You said that beautifully. Power of a power says you can multiply the exponents, so this will be p to the 10th. So if that was it, if that was the whole question, then I would be done. 9p to the 10th. But that wasn't the whole question. Now there was this. So let's write that down on this line, and I'm going to write it in a way that's going to help me. Well, how does that help me? Because here's the part that I skipped over that I assumed you understood. Here's what you should have done mentally. That should have come over here. Now, 4 times 9 is 36. What's p to the 10th times p to the 2nd? What property is illustrated there? Cherie?
The product of powers probably.
Product of powers. And what does the product of powers say that we're allowed to do?
We're allowed to add the exponents together when the base is the same.
That's right. When the base is the same, add the exponents together. And so now we have the 12 to the 12th power, and now 4 times 9, that's how we get the 36. And that's how we get that answer. Now we did questions much more complex than this, so honestly this should have seemed easier to you than this. Which one is more involved? These two or number 24? So I'm not saying you're a bad person or anything, but I'm just pointing out that we did 3 questions, the 2 examples and the checkpoint, that were much more challenging than this one. Okay? Okay, well remember, it's not distributive. So if another mathematician stepped into the room and they heard you say that, they would take me outside and beat me. Because that is really inappropriate in the world of mathematics. I'm just trying to help you see what I see, which is that it's similar to, or has a similar feel to, the distributive property. But it's not distributive. It's using the power of power. Okay? Kamoy? Did you have a follow-up, or that was... Now we have to take you outside and beat you. Okay, I'm just teasing. Okay, any other comments or questions? Okay, draw a line across your paper. Your homework is page 508. You're doing numbers 4 through 48 even and 52 to 56 even. That's a total of 26 questions. And your chapter 8 test will be next week. And you need to read the next section. Very important.